Okay, we are back for part two of chapter 5. So we are going to talk about some of the accessory structures of our integumentary system. So the first one we'll talk about is hair. We can find hair pretty much everywhere on our skin, save for the palms, the soles of our feet, our lips, our nipples, and certain parts of our genitalia. The distal segments of our fingers and toes do not contain hair either. So every single hair arises from a hair follicle. So your hair follicle is the portion of the dermis or a covering where your hair sits. It's not a part of the hair itself. So it's in invagination of the epidermis, which goes into the dermis is another way to say it. So the hair shaft is the part of the hair that protrudes above the skin surface, and then the root is below the surface, with the bulb being at the very bottom of the follicle. So we can divide our hair into two different parts. We have a hard cortex, that's the outer layer, and then the softer center is going to be the medulla. So the cortex is covered by a layer of overlapping cells called the cuticle, and that's how it holds itself in the hair follicle. Down at the hair bulb at the bottom of the follicle is where new hair cells actually are made and division is occurring, and then it pushes the hair up. So this hair bulb is right on top of that dermal papilla where all the blood vessels and nutrients are. Remember that papilla is an extension of the dermis that protrudes into the bulb. So we have the dermal papillae that are kind of like the puzzle piece into the epidermis where they fit together. And so a hair papilla is one of those little hills specific to a hair cell. So hair grows in cycles. It has a growth stage and a resting stage. So they are exactly what they sound like. During the growth stage, our hair is going to go through the process of mitosis within the epithelial cells of the bulb. As these divide, they're going to get pushed towards the top. They undergo the keratinization process similar to our epidermis, but they're obviously not going to go through the process quite to the point of being as hardened as our skin. During the resting stage, the growth actually stops and the hair is just held within the follicle. That bulb is no longer dividing. So once it goes through its resting stage, another growth stage will begin. And so a new hair begins to be formed from the bulb and the old hair will fall out. So not every single hair on our body has the exact same growing stage and resting stage. For example, our eyelashes enter the growing phase for about 30 days, and then they are in the resting phase for about 105 days prior to a new cycle starting and our eyelashes falling out and being replaced. The hair on our scalp, that can grow for up to 3 years, and it can be in a resting phase for 1 to 2 years. So you're talking up to a 5-year span of one hair or one lifespan of a hair. So hair loss typically is going to be replaced with new hairs. It's just the old hair falling out as the new hair begins its growth cycle. And as we get older, our hair is not quite as good at keeping pace. So as old hairs fall out, they're not always being replaced with new hairs. That's what happens when hair thins or we go bald. Just like skin color, our hair color is determined by the amount and type of melanin, not the amount of melanocytes. It's the amount and type of melanin itself. So of course, with age, the amount of melanin can decrease, which is why hair color can become faded, or it can get to that gray or all the way to white because it doesn't have melanin. I pointed this out way earlier when we looked at the cross section in part 1, but each hair has an erector pili muscle. This contracts to make the hair stand perpendicular to our skin surface or stand up on end. So as I said earlier, this is what is that feeling of the goosebumps, or when our hair stands up on end, it's an erector pili muscle that is doing that job. So looking at the hair here, we have the papilla for the hair, which is supplying our follicle and hair bulb with blood flow. Remember, the follicle itself is the covering. We have the hair bulb where new cells are being grown. It's going to spread up to the hair root. The hair root is covered by the cuticle, which helps it maintain its place in the follicle. And then when I go above the skin surface, we're going to have the hair shaft. Remember, each hair follicle has a sebaceous gland or an oil gland associated with it, as well as this erector pili muscle that makes our hair stand on end. The next thing we're going to talk about is a couple of types of glands. We've already mentioned these as we went through our different structures, but the two major glands we're going to talk about are sebaceous glands and sweat glands. So the sebaceous glands are simple. They're called acinar glands. They're branched, and they typically are connected to a duct to the superficial part of our hair follicle, or the upper portion of our hair follicle is where the duct is going to empty. They produce this oily substance that is rich in fats or lipids. It's called sebum. And so sebum is released by the process known as holocrine secretion. You don't need to know any details on how that works, but it is then the end result is lubrication of the hair and our skin surface. So this